For problem 21, similar to the problems that we just did from 11 through 20, I'm trying to figure out first intercepts, but I like to always look at my graph and identify the intervals on which it's increasing and decreasing. So we use red for decreasing and green for increasing. I think I'm gonna have to get a better green marker because it's hard to see that on the video. But anyway, for part A, we're trying to figure out the intercepts. Well, the intercepts, we have an x-intercept of -2, 0, another x-intercept of 2, 0, and then we have a y-intercept of 0, 3. So we can list the intercepts like that. And then we want to come up with the domain for part B. We want the domain and the range. So the domain would be, again, all of the x values being used to graph the function, and we have from -4 all the way to +4, and there are no breaks in between, so we're going to include all the real numbers as well in between -4 and +4. Well, the range, the lowest y value would be 0, and we go from bottom to top for the range, so the lowest y value is 0, the highest y value is 3, and again, no breaks in between, so we're using all the y values from 0 to 3, including 0 and 3, to graph this function. And then for part C, we're listing the intervals in which the function is increasing, decreasing, or constant. So again, the increasing intervals are the ones in green. So from -2 all the way to 0, as well as from 2 to 4. And then the decreasing intervals would be the red intervals from -4 to -2, as well as from x equals 0 to x equals 2, the y values are getting smaller. Let's see, took 2 minutes for that one, so maybe we can do number 27 in another 2 minutes. So for part A, let's go ahead and mark first of all the graph, and we used yellow to represent the intervals on which the graph is constant. So we're going to use yellow for those two. We have red for that interval, the y values are getting lower, and then we use green for the interval on which the y values are getting bigger. So, but we'll get to that. Part A is the intercepts, and we see one intercept right there of 0, 1/2, that's our y-intercept, and then we get the coordinates for that x-intercept of 1/3, 0. And then we get another, I don't see, okay, so it doesn't list the coordinates here, but we know that this being a straight line, so we're going to have to figure this one out. So this being a straight line segment, we know from one point to another we get the slope. So if the slope remains constant, meaning if we go from -1 to -1 to up to and over 1, so up to and over 1 gives us that point, meaning the slope is 2. Slope is up 2 and over 1. That means if we go up 1, we're going to go over 1/2. Up 1 and over 1/2. If we go up 1 and over 1/2, we get the x-intercept of 2.5 or 5/2, 2.5 comma 0. So I'll just leave it as 2.5 comma 0. It looks like 2.5, but you can't go by what it looks like. You have to understand that if the slope is up 2 and over 1, then it would be up 1 and over 1/2. Up 2 and over 1, up 1 and over 1/2. I don't know how else to, I'm trying to think of what else to say for that, but I don't want to restart my video. So if you need help on that, let me know. Part B, the domain and range. The domain would be all real numbers, x, so all the x values that are being used to graph the function, -3 all the way to 3. And that's the domain. And then the range would be, again, all the y values that are being used to graph the function. The lowest y value is -1, we can see that. And then the highest y value is 2, so the range is from -1 to 2. And then the intervals in which f is increasing Increasing would be the green one. That would be from 2 to 3. And then let's scoot this up a little bit. The decreasing interval would be the red one. That would be from -1 all the way to +1. And then the constant intervals would be the ones in yellow. So that would be where the function's y values don't change. So from -3 all the way to -1, as well as from 1 to 2. So a little over 5 minutes for that video.